Okay, hi everybody. We're going to do another example of factoring here. And so we're looking at x cubed minus 2x squared minus 5x plus 6. I'm going to call this polynomial p of x. And when you take a quick look at this here, you'll notice that, again, grouping won't work here. No matter how I kind of organize these things and group them together and try to factor out something that's common, I'm never going to get a common binomial out of that. This is because my numbers here don't have any kind of common kind of base factors there. So what I got to use is the integral zero theorem here. So what I'm going to do here is look at that wow, there we go. Don't know what happened there, but I'm going to look at that constant 6. Okay, and so 6, if I break it down to its factors, it could be plus 1, minus 1, 2, minus 2, 3, minus 3, 6, minus 6. So there's a bunch of options here. Those are the ones that I'm going to check, and I check by plugging those in. So the very first one, for example, that I'm going to check here is I'm going to plug in -1. And remember, what I'm looking for here is I'm taking a number that makes that binomial there equal to 0. And when I plug that in, what I'm going to get as a result is the remainder when I divide that polynomial by x plus 1. Okay, that's just how the remainder theorem works there. And so if I plug -1 into that, turns out I'm going to get positive 8. So that's the remainder when you divide that polynomial by x plus 1. Okay, which just isn't very helpful here. If I take and evaluate that at positive 1, okay, that's the same as me taking this one, and I'm dividing by that binomial x minus 1. And when you do that, you get a 0 here, and that means the remainder is 0, which means x minus 1 is the first factor I'm looking for. Okay. Now, most of the polynomials you're going to get at this level here, it should be fairly easy to find that first one. We're not going out of our way to make it difficult for you to find that. Now, once you've got that, what we're going to do is divide out that factor that I just found. So, and I'm going to use synthetic division for that. So with x cubed, I've got a 1, -2x squared, -5x, and 6. And then what I do is I take the opposite sign to what I'm seeing in my binomial. So if it's x minus 1, I'm going to put a positive 1 there. And then this 1 drops. And then I multiply and I add. And I'm adding because I changed the sign. I changed that -1 that I'm seeing up here in my binomial. I'm putting a positive 1 out front there. So I'm going to add. If I had kept it the same, I would have been doing subtraction here. So -2 plus 1 is going to be -1. 1 times -1, -1. Add, I get -6. This is really encouraging. 1 times -6 is -6. And when you add, you get 0. That's my remainder, which is awesome because that basically confirms for me that x minus 1 is a factor. And then what I do is I take a look at what I'm left with here. And based on that, I can interpret that this is going to be x squared minus x minus 6. So that's the quadratic that I get as a result. Now let's take a moment and factor the quadratic, because factoring quadratic should be pretty easy at this point. You would have been doing this for quite a while here. So I'm looking for factors of -6 that add to -1. And I think the answer is pretty clear. That's going to be -3 plus 2 after you play with that a little bit, which means the other factors that I'm looking for are x minus 3 up here and x plus 2. And so there's just a fairly straightforward example of how you might use the remainder theorem or the factor theorem to factor a polynomial.